All right. Welcome back, App School, lesson 2, the third lesson. We have been interested in what we can do with Urbit to actually build apps. And so in the first lesson, we started looking at essentially what's the minimal working example. Like, what do we mean when we have an app or a program running on Urbit? What does that look like? And the answer is that similar to the way that a core is a battery and a payload, you have an agent that defines a set of code and interface with 10 standard arms. You have this core that defines that. And then you have the state, which you can think of as being stored in a database somewhere, that defines the things that your program actually knows about at any point in time. And so then the code can make changes to the program state or develop things by interacting with other agents or with the operating system. So last time we talked about Arvo, we talked about the operating system. How does Urbit think about and organize the world and the kinds of things that it can do? Now, today, what we're going to do is we're going to go back to agents. We're going to write more code, and we're going to start examining what it means for agents to interact with each other and to update their own state. And to do this, we need to actually look at the different arms, and the kinds of return types that are coming back from them. Now, we experimented with this some. We looked at things like, oh, there's a quip card cab this, for instance. Let's go back and take a look at, I think Bravo's probably, no, let's go to Alpha. Alpha, I think, is in some ways, actually, this was the only place we saw quip card cab this. So let's go ahead and write an agent that is a little bit more complicated than this to start us off here. So I'm going to take this one's, well, let's not even do, we'll come back to this in a minute. Sorry, 1 second. I'm just trying to simplify this down because what I want to show you is, okay, this is fine. This is fine. We're in a good place here. Okay, we're gonna write this agent in a minute. This is Charlie, Alpha Bravo Charlie, and proceed from there. So we'll look at the whole agent in a moment. What I want to look at right now is the way that we have a mix of default arms for things like on watch, on leave, on fail, and then fully articulated arms that do a lot of things, right? Don't even worry about the particulars of the code at this point. Just worry about that we have arms that we've decided to write out that they do something specific, and arms that we've just ignored for whatever reason. It turns out that most of the time, unless you're writing a more complicated agent, you will leave 3 to 5 arms as the default settings anytime you work with them. So for instance, this agent has no interactions with another agent, so there's nothing to do in on agent. It has no interactions with Arvo, so there's nothing to do in on Arvo. It has no special instructions if it crashes, so there's nothing to do with on fail. And so in all of these cases, we simply leave it alone. We just say, there's a default message. You'll remember that when we ran this before, we could run things through Bravo. Let me make my text just a little bit bigger here, which is a pain because I can't fit quite as much on my screen, but I think it'll make your lives easier. And let me see if I can scroll back up and find, see, so Bravo running. Okay, so Bravo's running. All right, so remember we could do things like poke Bravo with a noun, and it would give us a message that said unexpected poke to Bravo with mark noun. That is what the on poke default agent is doing for us here. It is simply saying, I received a thing. I don't have anything else to do with this thing. So I'm going to fall back to my default handler, which in this case, produces no results, does nothing for me. Now, more commonly, we are going to want to accept information and then modify our agent or whatever we have. So we're going to adopt a pattern where I think onPoke is a good example of this here. I'm interested in lines 11 and 12 here that I've highlighted. So onPoke receives a mark and a vase. There was another term that we used for a pair of mark and vase earlier. Do you remember what that was? We ran into this 2 weeks ago. Yeah, so that's a cage. So what we're going to be doing, so we could also say tis cage. This terminology, if you haven't run into this before, and you may not have, depending on what you've looked at in school or when you went through whatever, this terminology means that we're going to define a value with the type mark, but the name of it is going to be mark. So the mark that we're receiving, we're simply calling mark. The vase that we're receiving, we're simply calling vase. And so later on, when I talk about, oh, is it mark, is it vase, I'm actually referring to the instances of those in this case. So it's the same thing as if I had said this in both those cases here. But it's a shorthand that you'll see used in Urbit as you work through things. The next line, quip card cab this. This was kind of a strange one. And this is equivalent, it's a mold builder. We've run into mold builders before. And basically it resolves to this. The state is the type of the thing that we're in right now, which is this. So it's going to resolve to a list, equip card cab this, and so this is going to resolve to a list of cards, and then whatever updated state is at this point. Couple questions in the chat. Number one, is it common to use default arms in moderately complex agents? Yes, so we will actually use these in two cases. One of them will be in places where we don't have any special handler. So in this case, we have no special state set up. So we just use the default initializer. The other case will be if we have a switch statement, which we haven't really gone through here, where we're handling multiple cases. And if there's a case that we don't encounter, we don't deal with, then we'll fall back to the default action in that case, which just prints an error message and crashes. Which, for Urbit is typically about what you want. There's another question here about not being able to see lines 11 and 12. Yeah, my form factor for this, so I can fit my notes on the screen, is to make everything vertical. So it's kind of an odd shape in Zoom, and you may have to maximize your screen or something to get it to play back in a comfortable way. I guess if I keep things near the center of the screen, that might, well, actually it won't let me scroll up because I'm already at the top. So play with that, and you should hopefully be able to see it, and hopefully the screen sharing is not giving you trouble there. All right, so when we build agents, what we're concerned with then is this any arm that we work with, we need to be able to deal with two kinds of things. One of them is a list of cards, and then an updated state. So Gall agents are going to communicate using cards, which is basically a certain kind of move. Last time we talked about moves, we had tasks and gifts, and tasks were things sent to Arvo to tell other veins what to do, and gifts were information that we received back and had to decide how to interact with it. And right now we don't need to sweat any of that terminology. We just need to know that moves are messages that we're sending to the system. Cards are a certain kind of message that they're the thing we're going to be working with in Gall. Urbit is a fairly large operating system. There's a lot of differentiated kinds of things you can do with it, but we're going to be working with Gall agents. And so in any case, what we're going to be doing is we're going to be producing a list of cards that are going to interact either with other agents, which could mean the same agent that we're running, but on a different ship, or it could mean other agents on the ship we are currently on. So if I want to talk to Portal, if I want to talk to Pals, if I want to talk to Group, I can send it a card. And then state changes. Most commonly, we say cab this. Cab is, let me write it this way. I believe it's buck cab is the mark here. And so what's happening here is we're saying, give us the type of whatever the thing is that we're using. So for instance, if I were to do buck 6, then it would interpret this as an atom. So if I had some other kind of value like that, then it'll interpret it as this value. And actually, in this case, it looks like it's interpreting it as the constant 6, unless so it's interpreting as actually as the constant 6, and just passing through into whatever thing it is. But cab means the type of this as an example. It's kind of an odd usage. So think of this as a boilerplate that you will use. It just saves you trying to figure out, how do I refer to the current kind of thing that my state is? Do I need to modify this every time I change the state, or I change the bowl, or whatever else happens? It just simplifies it for you. You're just saying you're going to return a list of cards, and you're going to return something that is the same shape as what you have right now. It's the same kind of thing you have right now, but maybe you've made some changes to values in it. So what is a card? What does a card look like here? I really don't like this SIG structure here, but let me show you what it does. SIG post pens a SIG as opposed to producing a list. And I don't like that terminology. And I think what I'll actually do in both these cases here is I'll replace it with something I think is more legible. All right. And the other thing I think I'll do is I will reorder this to this. All right. Now, so what actually gets returned? Worry about lines 22 through 25 now. In this case, we're going to return a cell. So if you look at line 14, we're returning a list of cards in the state. We're going to return a cell. Line 23 starts a list, and that list consists of cards. These are basically the events that Gall knows how to communicate in. There's kind of a standard structure for these, of course, right? Because we can actually tell what they are. And in an example like, let me open up a new. Oh no! Oh, that's what happened. Sorry, I accidentally tried to save it. And all right. All right, your basic model is you're going to have a cell. So if I write this as a coal tar, that means I'm creating a cell of running values. The head of this cell is typically going to be pass. It could also be gift. We'll look at a gift in a moment. Remember from a moment ago, a gift is a returned value. So this is what I'll call an outbound value. Or task. It's a thing we're sending to someone else. We're saying, we're initiating some action. So we're going to pass that. We're always going to head tag it with the name pass. We're going to give it something called a wire. Now let's see. So let me write it out like this, just so we have head tag. We call this a wire, but basically this is unique ID. This is written as a path, so it's written with FAS values, so I can actually just put any text I want to there, and this resolves to a path. And this means that I can uniquely identify the request it corresponds to if I receive a return value back. So, you know, if I'm requesting several updates from another agent and I would like to be able to tell these apart, then I need to make sure that I give everything a unique ID. So maybe I timestamp it, or I have a sequential counter or something like that that I'm using to modify these. But this will allow me to refer to these uniquely without getting confusing my messages when they come back to me, because they may come back to me out of order. Now, after this, we have a choice. We can either send something to Arvo or to an agent. So here we're going to make that decision. We're going to give it the name Arvo or agent. So if I give it Arvo, then I need to give it a value of a vein to where it's headed. So I'll call this to Arvo or to agent. In the case of Arvo, then this is all defined within Arvo. So this is the target vein. So I'm going to be talking to, what did B stand for? Which one was that? So that is Bain. That is our timer vein. So if I were to go look at the API, the documentation for Bain, I would see that it allows me to do things such as wait. And so this is a particular task. This is a Bain specific task that I'm asking it to do, and that it expects a time. Okay, and it expects a time like an absolute time, like it's waiting until some event happens. So it's not a relative time. I'm not telling it directly do this 1 minute in the future. So I couldn't say, if you haven't worked with time before in Urbit, there's a PATDR ARA that stands for relative time. So you know, if I were to do 60 minutes, then this would convert to 1 hour. So I can't tell it how long to wait. I have to tell it when to wait until. So, you know, commonly I would say something like add 1 minute to my current time. This would be a PATDA value. And again, this is specific to this particular task. And if I were requesting other information, like if I were talking to Air, if I were talking to Jail, then I would request this information in another way. But this is the structure of an Arvo card. All right, so this is an outbound task to Arvo. Now, what I've done at this point is I've set this up expecting to get some value back, in this case from Arvo. So Arvo outbound cards return through on Arvo. Agent outbound cards return through on agent. And so there's going to be 2 different arms in your agent that will handle both of those cases for you. We'll look at how to set that up in a moment, but this is a thing that we would actually just directly treat as a, you know, as a single requester. So, you know, I could pass this out of any event. And then when I receive a wake up gift in return, when the card comes back as a gift in return, then I will have to decide, okay, how do I, you know, what do I do in response to that? Do I update my internal timer? Do I update my state? Do I check for other information? Do I set this card again? And so forth. So we'll look at some examples of doing those kinds of things. The other one is an agent card. So we'll also say this is an outbound value or task. All right, so this is a tuple, right? This is not a list. It doesn't end in a sig. It is just a tuple of a certain length. It's a, you know, cells composed together. So in this case, I'll pass. I'll have some wire. I'll call it some other wire. It's very common to do things like Scott the current time. So if I were to convert the current time to text, I can use Scott to do that. So that's actually the current time as text. And so if I were wanting to include that as unique information as an identifier in a path, then Scott SendDA would do that information for me. And so that's it's not the only way. Sometimes people will use entropy, or they'll, like I say, they'll have a counter or something to keep track of it. But anyway, you want to have some capability to make these things unique. And now we would call this an agent card. And now we have to decide, like, what are we, what information are we passing to the agent? Typically, there will be a target ship. So in this case, I'll say sample PALNet and target agent, right? Like, where is it actually headed? It could be an agent of the same name that I have right now. Could be a different agent. We'll see this both. The kind of thing I'm doing now, this is interesting because I can actually specify, am I poking it? Am I doing something else? There's different, different kinds of interactions that I can have. And then I have to pass it a mark and a vase. So typically that'll be something like this, whatever the value that I'm sending to you looks like. So we'll see this as we look at the code. So for instance, if I go look at this one here, what am I doing? I'm passing along a wire named pokes. That's what we were calling a unique identifier. It's not unique here. Okay, so let's stick a pin in that and come back to that in a moment. It's an agent. I'm passing it to a target ship that I'm getting out of this action value that's defined up here on line 16. We'll talk through that in a minute. And I'm going to poke their Charlie agent, which is the agent I'm in. I'm going to poke it with the mark that I received on line 11 and the vase that I received on line 11, and just call that good. So I'm just poking some ship with the same information that I received. Hopefully that's pretty straightforward here. Now, I didn't have a unique identifier on my wire here. Why do you think that might be the case? We support this, that we have unique identifiers here. Why don't I go ahead and generate a unique identifier? If I look at the rest of the agent, 42 and 45 give me a hint here. So if my return values are processed in onArvo and onAgent, and I don't process any return values in onArvo and onAgent, what does that imply?
It doesn't matter.
Yeah, I'm never getting information back that I ever have to differentiate again in this case. Exactly, right? Like there's nothing I'm doing that requires me to ever be able to tell these apart in this case. Now, that wouldn't be the case for a lot of other things, right? So let's say you're writing, groups, and you have like a threaded chat room or something like that. Let's see. Oh, Zoom is doing weird things. Nordbird started drawing and it like took over my screen. You stopped drawing, but it didn't take away the blocker in the middle of my screen. Oh no, it's like stuck. Okay, 1 second. Didn't know that was going to happen. All right, let's see if resharing will get rid of that. All right, we good there? See all, you can all see the whole screen again. Oh, Nordbird left. Come back. Okay. So let's look at, yeah, there's different things we can get back. All right, let's write another agent. So this is some agent code, but let's actually go ahead and like sort of write this from scratch. So we're gonna bar. Let's see, from last time we had a few different ways of generating an agent. We talked about you can do new desk, which creates a minimalist desk for you, but we have to figure out the mar and the lib to copy, or we can bar merge and do it from base. Let's go ahead and do it this way because I want you to see the subtleties that are involved with this. So I'm going to bar merge Charlie hour base. Now, the thing that I said you have to be careful with is that it'll override the system when you bar commit this, because the agents that are running on this copy of base will take over the agents that are running on base, because in the current version of Urbit, agents are distinguished by name, not by desk and name together. That may change in the future, but right now that's the case. So let me open a new terminal here. And actually, let me go ahead and bar, and then I need to bar mount Charlie. If I can spell Charlie. All right, there's Charlie. And actually, I don't actually need to run into the other window yet. I can just look at the fact that I have Charlie here. All right, we're going to start somewhere we didn't start before. We're going to start in Sir. Okay. Sir is a set of structure files, and if you look at these, open any one of these up, they generally consist of bar-send cores with a bunch of lustbucks. These are like header files. These are shared type definitions that different parts of your system need to know about in order for an agent to work correctly. You don't want to stick all of these in your app because other parts of your system might need to know about this without importing from your app. Properly speaking, they're not really a library. They're not doing quite the same thing as a library. So by convention, we're going to define these in SIR, and these will be structure files. So Charlie, let's save this as charlie.hoon in SIR. So you can see that I've added this here. Let's say there's going to be a bar send core full of lustbucks. By convention, we normally populate these with something that we often call it an action, or maybe an update or result or something like that. There's a few names that get commonly used for these. But what these are going to represent are the kinds of interactions that we can have with our agent. We're going to use this to validate the things that can be done with our agent. So we're going to connect these into the mark files. We're going to connect these into the onPoke arm, and they'll show up in both cases. Do you remember what a bucksen defines? From way back in Hoon School. No takers on bucksen?
It's a tuple.
Yeah, so it's a name tuple, and we're going to use this to head tag the kinds of things we can do. This is a really common pattern in Hoon. Right, so we're gonna give it a head tag name that's going to be a term, and it's going to allow us to distinguish the kinds of things that we can do, and then differentiate the kind of information that we can extract from this. And that should end with a tis. All right. So what this means is that Charlie, we're going to be able to push a value onto our local stack, or we're going to do what I'm calling a pop here because that's the other operation from push, but since we're not actually like returning the value back, it's not really a proper pop. I guess it's just more of a delete. We'll let it ride for now. Anyway, it lets us push a value on or remove a value from the stack. So from the stack's perspective, this is going to look the same. So we're going to be able to build a list of values up and then take them off the end as we can grow and do this. So, we can do this to a target ship. And then when we pop, we're deleting the last value on that target ship. We're not doing any validation about, do I have permissions to do this? Whatever, I can run this on multiple ships. They can affect each other. We're just going to live with that ubiquitous ability right now. By convention, now, inside of MAR, am I still inside of Charlie? No, I'm not. Let me make sure I'm doing this in the right spot. Inside of MAR, inside of Charlie, I need a new folder called Charlie. And inside of that folder, I'm going to create a mark file named action, or named whatever the same name as as each action has. What this mark file does is it defines a way for us to get from a noun input or from a JSON input or whatever else we define here to our target structure file. In the past, we have just been, when we interacted with Bravo here, I was passing information in Pam noun, like with a mark of noun. And, this worked, it passed the information in, but there's no validation on it, right? Like I could pass any possible noun and it wouldn't work. So now I'm going to be able to do validation on it. I'm going to be able to use this mark file to transform in between these, but transform a noun into an action to a noun, and so forth. All boilerplate. You can almost copy and paste this for everything you do, at least through App School. Question in the chat: when creating multiple fake ships, how do I go about naming them, e.g. Zod, Zod 2, Zod 3? Okay, this is a fake ship has to have a valid name, and even locally on your fake ship network, your fake network, you can't run two ships with the same name. So you can't have two Zods running locally. They'll block each other. So if 0 is Zod, then it's often conventional to just run the next few agents here. So 1 is Neck, 2 is Bud, 3 is Wes. So you can just pick other galaxy names. With galaxies, this is straightforward. There's some interesting problems you can run into if you're doing planets talking to each other, because planet routing still works the same way, where it would have to go through a star sponsor I guess just through the corresponding galaxy and back down for you to do peer discovery, even on the same local network. So you can it's harder to work with planets because of that locally. So we prefer to work with galaxies because galaxies basically in the urban address space network system, they know what each other is. So you'd create a fake Zod, you'd create a fake Neck, a fake Bud, and then you would have 3 ships that would be able to talk to each other. All right, so we have a structure file, we have a mark file, and now we need an agent file. And let me go ahead and save this first, and then I'll figure out how to get this to you efficiently. Let me do this in 2 steps. The first one will be down through on save. And as a reminder, if you just copy, it tends to butcher the double spaces from Zoom in the chat. So if you click the three dots to the right, there's a copy option, and that should preserve those double spaces everywhere that they need to be. All right, so that's there it is in two fragments there. All right, let's talk through what's going on here. So first off, we're loading Charlie. FASHEP loads Charlie, so loads stuff from the SIR directory. tar means that we're loading it without keeping the namespace. So everything in Charlie, like action, just gets loaded with that name. So anytime I talk about action now, which I will later on, like on line 29, it's the action that's defined in the structure file, Charlie. Then I'm loading default agent and debug. Excuse me, nothing strange about those. You've seen version state, you've seen state 0, but now in state 0, and I think we had this in Bravo, we did have a list. Now we're actually going to do something with this list. So we have a state 0, which is head tagged with 0, and has a list of values that are just pat, just raw atoms. Aliasing cards, so every time I have a card, I don't need to type out card agent gal. This is the same boilerplate that you've seen before. This and default. Default is a way of activating default agent against the current subject, which is the core that I'm in. It's kind of a, I believe this last one is a verbosity flag. So if we change that, then we should see different behavior in how verbose it is. So maybe I'll change it to a PAM instead of a bar and see what difference that makes. All right. On init, no change there. On save, returns a vase of the current state. On load, does have a rule to return, in this case, an empty list of cards, and then the current state updated to be the unpacked old state, which in this case is a null op. Nothing happens, right? Because it's the same and the same. I shouldn't really say null op. I should say it's idempotent. Accepts the value, doesn't change the value, returns the same value out. All right, and then most of what we're interested in looking at here takes place in onPoke. Let's go ahead and bar commit Charlie and see how it behaves. And I need to send it a tuple of a ship and a value. Oh, bar install send Charlie. Just turn it on. Oh, there we go. Let's see. Nest need, nest have. That might be from the poke. Let me see if this is running. Yes, Charlie's not running yet. So install Charlie is failing on. Oh, what's wrong? How do I install? Install our Charlie. I'm gonna have to install the local version. Ah, okay, good. It crashed there and saved me from making a terrible mistake, which is I forgot to edit my, I guess that's the wrong one. I need the Charlie desk.bill, which includes everything that's supposed to be running, which should only be Charlie. So anyway, I want to write this as a list in desk.bill. Now should work for me. So now if I bar commit Charlie, that should change desk.bill. Bar install our Charlie, and then we should be running. App Charlie failing on 19. Did we change? Well, the only thing I changed was that, and so I guess it might need other information in that case. Let's try this. Okay, good. That seems to be running. So if I do cold Charlie less debug, okay, then I get what my current value is. Okay, so apparently if I were to change this, then it would want some other kind of information with it as well. Probably a verbosity setting, because there's different verbosity settings you can get with that. All right. All right, so now if I want to poke Charlie from the Dojo prompt, all right, so if you bar commit Charlie with the code I have above, if you bar install our Charlie, and you can do Charlie less debug, and you get 0 values back like this as a message, then you have it running at that point. Now what I'm going to do is I'm going to poke it, and before the way I poked it was I poked it with a noun. So we're gonna try this. I need to tell it to push a value to, in this case, I will specify Zod, and I want to push the value 100. Okay, and it crashes on something that looks a lot like what I had a moment ago. So let's go down here to on poke and sort of trace the logic in. And actually, let me show you the alternative that will succeed, which is if I push it with the Charlie action mark like that, then it does succeed. All right. Now, what happens is this poke comes in, and it's a pair of mark and vase. So the mark, in this case, in the first case, came in as noun, and in the second case, came in as Charlie action. And then the vase was a vase of this information on the right. So this comes in as raw data with type information attached to it. That's what a vase is, right? It's a pair of type and value. So we have those values there. And the first thing I do on line 28 is I assert that the type, what tis compares type, the type of my mark is Charlie action. So this is a data validation step. I'm saying, am I receiving information that nests inside the type Charlie action? And if I don't, if I try literally anything else, I could make up other kinds of values here, and it's going to give me an error at the same place. It doesn't know how to deal with that information because there is no mark. Well, I mean, one, there's no mark by that name, but two, it doesn't match here. So this assertion, this whatgar, fails at this point. If it succeeds, then my next step is to zap gal it. Zap gal, if you look at the docs, it has some very technical way of describing it, which is like, it's like elevate a dynamic value into a static context or something like that is the way that it puts it. But basically what this means is we have some value that we do not know when we compile this program. When we write this program, we don't know what someone's going to type in here. But what we want to do is we want to take that vase and we want to run it through action, which action is a type, it's a mold. And so if I go to SIR and I look at action, what's actually happening is it's just saying, does it match one of these two named tuples that I have available here? Is it a push or a pop? If it's not a push or a pop, and if it doesn't have the right values after it, then crash. It doesn't fit. It doesn't nest inside of it. So that gives you very strong data validation here. But after you validated that data, you have that information available as ACT. And then what I'm going to do is I'm going to switch on the head of ACT. The head of ACT is push or pop. This is why we head tag things, because that makes it easy for us to make a decision based on what the kind of thing is, because we labeled it right up front. We stuck a big sign on it, says this is the kind of thing my user is trying to do. So we're going to switch on this, and the structure of this switch statement is we have the value that we're switching over, and then the type of thing that value might be. It can be a push or it can be a pop. If it's a push, we have some associated things that we do, but ultimately we pass a value to the agent through it. And if it's a pop, then we pass a value in this way as well. Yes, what I said is correct, but actually there's an easier way to understand it too, for those of you who are still looking at this. So what happens is I can poke any ship. So I'm down here at the bottom. I can poke neck. I don't have neck running. And so this just sits in Ames, waiting for someone to start up neck. So if I had created the shift neck and I had neck running here, then I'd be able to just push and pop back and forth. Since I can't specify the ship, I wanted the Charlie action version of Tazad. And now if I look at what my current state is, I should see 100, 100. Yeah, 200, 100, 100. So everything's getting pushed on the front here. And if I want to pop from the current ship, then I can see that I popped off that first value. So it's growing at the front and then shrinking at the front. Because that saves me a list traversal, like traversing all the way to the end of the list, which is more efficient. Now, inside of push, there are a couple of different cases here. The first case is a check on line 32, and this is a data validation. What is this checking? Tis our dot bool target dot action. So what is this saying?
If the ship is the current ship.
Yes. If I'm on my own ship, then I have permission. Right? There's nothing weird, there's nothing sketchy about it. I'm on my own ship, run it. I mean, there might be weird and sketchy things you can do on your own ship, if you're installing whatever code comes to you, but in principle, at the app school level, we can trust it. So what we do in that case is we return an empty list, and then we return this with values replaced by the value in action prepended to the list of values that we had previously. So I'm modifying my current values, and when I return it out of this, Gall takes care of just changing the state that it's tracking, the state that it's actually holding on to in this. Right. So if I were to write this out in a very, very formal code here, which is not a bad exercise. This is what that would look like. It's a cell where the head is an empty list card, and the tail is this with a certain change made. And if I didn't mess anything up, that should work. Good. All right, so like it still runs. This is saying the same thing. Okay, if it's not us, then I am asserting. Wait. So I'm saying what is the second assertion doing? So the first assertion is saying, if it's targeting me, make this change. Oh, I think that's kind of an odd way to say it. Okay, let's do it like this. Okay, otherwise, if not targeting me, then I'm saying if it comes from me, which must be true, sorry, what's confusing me here is why I thought this was necessary. This assertion seems to me like it shouldn't be required. All right, so let's do it this way. I'm gonna write out the same code that I have below more explicitly. Yeah, so if it's not going to me, it's going elsewhere, then I'm going to pass to the agent on that target ship the mark in the vase in a list of cards. So the col sig here is for the list of cards. And then I have no local changes to make in that case. All right, so logically, this comes to the same thing and should compile. Yeah, I don't know why I'm actually asserting this, because it seems like it seems like it's coming from me if I wrote it. So this should be equivalent even if I don't have this assertion here. Okay. The other case is that I need to pop a value. I need to delete a value. So if targeting me, make a change. No surprise there. Otherwise, yeah, same strange thing. Not targeting me, then send elsewhere. And I could actually copy this same code here. Should just work. Okay, let's look at line 48. Which maybe I should expand out the same way. So this is a col hep of list card sig, and then we have a sen hep of this values. All right, so what does line 50 mean? Why is line 50 necessary? Why are we writing it this way? So what I'm saying is, if this is me, then I need to not send any cards, but I need to delete, well, but I need to either return nothing if my list is nothing, or I need to return the tail of my list, right? Like delete, chop off the head of my list and just keep the tail of my list of values. Why do I have to do this check on line 50? Why do I actually have to check if my list is empty and then explicitly return null if it's empty? I know you've run into versions of this problem working through Hoon School. Right? Think about what's going on with a list. Hoon has problems where if it doesn't know that a list, are you going to say something, Winter?
Yeah, I was just going to say it doesn't know whether it's a list or not at this point.
Well, it knows if it's a list. What doesn't it know?
If it's
it doesn't know if it doesn't know if it's an empty list.
Oh, yeah. Okay. Yep.
Right. Like it's this weird distinction that we have to make, right? Where it can be a list and we actually don't know if it's an empty list or a populated list. So that's what we're doing here. We're saying if it's an empty list, like don't crash, just return empty. That's what sig is doing. And if it is not empty, then return the tail. So that's the check that we're doing here.
Yeah, so you're checking for the base case.
Essentially, right? I can't
Hmm.
return the tail of an empty list. And Hoon will not let me do it. Hoon will fail at compile time. So if I were to do the version of this that was just t.values, let's try that. All right, it fails on a find fork, on can't find t.values. T.values is not guaranteed to exist because the tail of the list only exists if the list is non-empty. So in any production code, even in most development code, like you have to have these kinds of things to make Hoon happy. Hoon is not happy otherwise. All right, so that's what a push and a pop look like, and the way that we can validate on those. We also define a peak, which we've not previously had. So .ket was a scry. This was what we were using to look at values inside of our operating system, inside of Arvo. We can do with agents as well. And so as you'll recall, the first thing that this had was a type, a mold that whatever it got back had to conform to. And then the vein and type, so a GX. And then the agent and the path that we're looking at here. And the final value on that has to be, typically it's noun, but it's the mark of the thing coming back. All right, so .ket, now this comes in as what it calls a unit cage, because there's two ways it can crash. It can crash because the scry fails, or it can crash because the scry path doesn't exist. And so we end up returning a unit cage to distinguish those. So we're going to scry at a path. In this case, the path is values noun, which is what I'm checking here. And I'm returning a unit cage. And so my cage is head tagged noun with a vase of values. It's a very compact kind of thing. I could define another one here. I could name it last, and maybe this refers to the head of values. And actually, I probably have to do a what sig on values, sig i.values, something like that. So let's try that. So now if I check last, I should get 300 back. Something's unhappy about the, oh, it doesn't come back as a list pat. That's why. That would just come back as a pat, right? So that's the last value in my set there. So peaks are read-only operations, right? A scry is a read-only operation. So it's a quick check. I just want to know some information about the state of your agent. They're going to feel very boilerplatey. You're just saying, typically you'll wrap it in a noun and just put everything together and throw it out this way. Now, the other kind of interaction that you can have is, so a poke is a one-way change, right? Like I'm sending you an action, and maybe I get a response to that, but I don't necessarily get a response to that. So in this case, I don't know if my poke succeeded, right? I was poking neck and nothing was happening because neck isn't running. And, my agent has no idea, right? It has no way to tell that information. The other, and then a peak is a read-only single request. So both of those are kind of like one-off requests. A poke is a one-off action, and a peak is a one-off, scry is a one-off read-only action. The other kind of thing we can do, which is what watch and leave are concerned with, is we can request to have a standing update about information. This is called a subscription. And what we're going to do is basically have a list of kinds of information that we're going to expose to someone else. And anytime a change happens to some information, we can pass a gift back to all of our subscribers, anyone who wants to know what's going on. So for instance, when we are hosting a group on groups, right, on Urbit, everyone is subscribed to chat messages. And anytime a chat message, anytime I type a chat message and I send it, what I'm doing is I'm poking the group host with the content of that information. When that information is integrated into the group's log, then everyone who is a member of that group who is subscribed to that chat channel receives that information back as a gift. And then it updates their own internal state when that gift gets received back. So it's a very well-defined process for pushing these things around. Now, there's another agent we're going to look at. We're going to start looking at, but I think we're not going to finish today. And this is going to be Delta. Let me bar merge Delta hour base. One moment. All right, merge Delta hour base, bar mount Delta. And then Delta should appear over here somewhere. There's Delta. First thing I'm going to do before I think about it is change desk.build to run Delta. Okay. Now, let me give you Delta in two pieces as well. We're going to have a lot of information that looks the same as Charlie, which is, of course, why we're building this up one piece at a time. Let's see. Three messages this time. So Delta is also going to maintain a list of values. It is going to accept things through a Delta action mark the same way that we had a Charlie action. It is going to have the same action with respect to pushes and pops and everything. Like nothing changes in on poke, nothing changes in on peak. What's new is that there's now an on watch arm. And on watch is also going to return equip card cap this. It's going to assert that someone is subscribing to the values path, just saying I don't support any other kind of path. You can subscribe to values or you can subscribe to nothing. If you subscribe to values, then it's going to return to you what my current set of values is as an update. All right, so that's new. There's an update type, kind of like our action type. So we'll take a look at what that is in a moment. And anytime I change a value up here, like I was doing this values before, I was just returning sig like an empty list. Now I'm going to return a list of other cards, and these are going to be fact cards. So this is a give a fact along the path values. It's going to be a Delta update, and it's going to contain the information that is my actual change. So all of my, every time I get a change, anyone who's subscribed to my agent will receive information about the change that they got. So this is now a standing update that I can do for them. Let me save this as, let's see, I'm in Zod Delta app, delta.hoon. I need a SIR file. These will, of course, all be in the notes because there are a lot of these dinky little files that we have to mess around with now. You'll notice that now we've added to SIR, we have action, which is push and pop. Nothing's changed there, but we also have an update, which can either be a head tagged init, which is just an initialization, or it is an action, which is push or pop. So this is a neat way that I can just include all of the kinds of things in action directly in my update. So I could explicitly enumerate these, or I could just include the type of action. So update is actually a super type of action here. And then I will need a mark file delta that will be action.hoon and update.hoon. So action.hoon will look just like Charlie. That will be in mar delta. And update.hoon will also look the same, except everywhere that it said action, it will say update instead. And that'll let me distinguish at the dojo level and at the interaction level between actions and updates. I can still validate both, but I can tell the difference between them. All right, so now if I bar commit delta and I bar install our delta, delta should start. Okay, good. So col delta, Pam delta action. Yep. Show me in a little bit, okay?
Yeah.
And I can push Zod 100, col delta less debug, and I can see that I have a list of values there that I'm populating. All right, now what I told you was that Delta could also support people subscribing to the things that are going on here. But I don't do anything with this, right? Delta can't subscribe to itself. It can't subscribe to other things. So I'm going to introduce a new agent called Delta Follower. Delta follower.hoon. And then once we've introduced this one, I'll go ahead and wrap up today's lesson. So we won't be too much longer here. All right, Delta agent doesn't do a whole lot. You'll notice most of the arms are default arms. Watch, peek, init, save, load, arvo, leave, fail. They don't do anything. What does happen is I can poke it to subscribe with the unique identifier values wire to the path values, which is a watch type on Delta on a particular ship. So I can subscribe or I can unsubscribe. And when I receive information back, that'll come in through on agent. And if it's a fact, then I will print the information that I have. And I could do this between ships or what have you. I do need to update my desk.bill to include I just need to find the right desk.bill to include Delta follower, or it will not start when I run this. So Delta, send Delta follower. All right, bar commit Delta. All right, so Delta follower is booted. Delta follower, let's see what it did. It doesn't have its own state. All it does is print a message every time it receives an update. So I should be able to tell Delta follower to subscribe to Zod. Actually, I need to give it a Pam noun mark. And then I can tell it to subscribe to Zod. Okay, so I got the initial list of values that Delta knew about. And now every time I change Delta follower will also output this message saying, oh, I received an update that the value has changed. And this would work across ships. If I were running a NEC and a Zod, I could subscribe across ships now. And anytime a change happens on one ship, I'll see it happen on the other ship as soon as that notification makes its way back through the network. So this is pretty neat because I can just handle being able to pass this information back and forth. Now you'll notice that there's a fact, which is the main thing I'm getting back. It's the gift I'm getting back. There's also two other types of signs that I get back in OnAgent. There's a watch ack and there's a kick. So a kick means that for some reason, my subscription failed. There's a number of reasons that things can go wrong with trying to subscribe to someone. Maybe you don't have permission, whatever. By convention, you attempt to resubscribe once, and then you accept the inevitable and don't resubscribe again. So you attempt that, and if it fails, then you don't keep attempting. The other is a watch ack. This is a watch acknowledgement. This means that you got told that things were correct. And in this case, that's what's handling the initial value here. When I receive the initial value, I'm getting, I'm printing subscribe succeeded. I'm displaying this initial value, and then actually, no, I'm getting the initial value back as a fact. Yeah, but I'm displaying the message that, here's my subscribe succeeded. I actually got to see the information that I was trying to there. Slog is basically equivalent to a SIGPAM. I could also just say it like this way. And that should work as well. So I can do it either way. So what Delta Follower does now is it allows one agent to track another. Right now, this is the way Gall agents are typically built. There's been some discussion more recently about shifting to a model called solid state subscriptions, in which we are thinking about passing you changes to your state and trying to make it so that your apps respond to what their current state is, less than to what the changes that they receive are at any given point. This is a pretty promising model, but right now, solid state subscriptions is in flux, and the interface for it is liable to change. So I don't encourage, if you're interested in it, we will probably do more with it in App Workshop, to which you're invited when we start running those later in the month. But I would not consider, I wouldn't consider it something that I'd want to start writing production agents in. So, if you're participating in the hackathon, for instance, that's take a look at solid state subscriptions, that's fine. If you're participating in in UAC, or you're thinking about building long-term software, then right now stick with conventional subscriptions rather than solid state subscriptions, because that will change. All right, so today we basically saw, how do we get agents to start talking to each other? How do we interact with agents in a more validated way? What do some of these arms do that we run into we didn't enumerate before? So next time we're going to start to elaborate more of the consequences of that and start to do fancier things with having agents talk to each other, coordinate, and build different kinds of ways of passing data and validating things and unpacking data that I'm getting from the web, for instance, which may be in a different format, proceeding from that point. So that's what we have for today. Thank you.